Okay, so we're going to go over the subatomic particles where you have protons, neutrons, and electrons. So in the case, before we talk about those three subatomic particles, we need to talk about two numbers, the atomic number and the mass number. So the atomic number is just found on the periodic table. And so here we have the periodic table. And so the atomic number is usually found directly above the symbol. So for example, boron has a periodic an atomic number of 5, carbon 6, and so on. And this just tells you the number of protons. So the number of protons indicate the number of, or indicate the element. So all carbon atoms have 6 protons. So that's what makes carbon carbon. It has 6 protons. So that's the atomic number. However, the mass number is just the mass of each atom. And so what you'll learn soon is that the protons plus the neutrons are equal to 1 atomic mass unit, and they are the only ones with mass. And so we say the nucleons or the protons and neutrons, that's how you determine the mass number. Okay. All right, so let's take a look at the subatomic particles. We have protons, neutrons, and electrons. So we'll talk about each one. So the proton is found in the nucleus, and it has a positive charge. It has a mass. Now it has a mass which is really small in grams. So we use a different unit when we're figuring out the subatomic particles mass. We use atomic mass unit. So the proton is about 1 AMU. And how can we calculate this, or how do we know this? We know this by the atomic number. What happens if you change this number? So if you change the number of protons, you change the element. So protons determine the element. Neutrons are also found in the nucleus. Their charge is neutral. Their mass is the same as a proton, 1 AMU. Now to figure out the neutron, we actually, so remember if I told you before, remember the mass number is equal to the number of protons plus neutrons. Now, I know if I want to figure out just the neutrons, I have to subtract the protons. But if you remember, the atomic number is equal to protons. So if I take the mass number and subtract that from the atomic number, I'll get my number of neutrons. All right, what happens if you change the number of neutrons? Well, obviously you don't change the element because you're not changing the number of protons. You actually get what's called an isotope. An isotope is just an element with a different mass number. So it's the same element, but different mass number. Okay, let's take a look at electron. Electron is found in the electron cloud. Its charge is negative. Its mass is like 1 over 1840 AMU. But we're going to say, in fact, I'm just going to erase that. For your sake, just think of it as 0, because it's so small, we'll just say it's 0. To calculate the number of electrons, you have to figure out, well, we'll say that if it's neutral for now, if it's neutral, so if I have a neutral charge on an atom, remember the only other charge that cancels out a negative charge is a positive charge. So in a neutral atom, if I have 5 protons, I need 5 electrons. They cancel each other out, right? 5 positives, 5 negatives. So in a neutral atom, the proton equals the electron. This is in a neutral atom. What happens if you change the number of electrons? So let's say you change the number of electrons, you form what's called an ion. An ion is just an atom with a charge. So it has a charge. It can have a positive or negative charge. Okay. Okay. And then what we like to do is we'll use either a nuclear symbol or isotope symbol. And these symbols, what's useful about them is just by these numbers here that are around the symbols, we can determine the number of protons, neutrons, and electrons. We could figure out if it's a positive or negative charge, stuff like that. So let's take a look at this nuclear symbol. So here we're looking at the nuclear symbol. So to the left, the upper left, you have what's called, this is the mass number. Below here, this is the atomic number. And sometimes this is not written because you can actually look it up. What I mean by that is sometimes we don't write this because if you know this is Ti, which is titanium, you already know if you look at the periodic table that it has an atomic number of 22. We don't always know the mass number because it could be what we call different isotopes. Also, what is here, it is missing, is this is the charge. Now, notice here there's no charge, so that means it's neutral. So in this case, it's neutral. But sometimes you'll see like a +1 here or a -1 or something like that. And that just means, it just tells you the number of electrons. But if you don't see anything, we assume it's neutral. The isotope symbol is similar. It just gives you the full name, and then this number is the mass number. And that's all you need to know. All right, so let's just run through a couple of examples. So let's say I gave you helium-4. And I said, hey, how many protons, how many neutrons, and how many electrons are there? Now notice, you can look up helium, and you'll figure out what are the protons. So if I look at helium, the atomic number is 2. So therefore, the protons is 2. Now remember, this is my mass number up here, right? So my mass number is 4, which means, remember, mass number is equal to my protons plus neutrons, right? So if my protons is 2, my mass number is 4, my neutrons have to be 2, right? Because 2 plus 2 equals 4. And then my electrons, if you'll notice right here, there is no charge, which means it's neutral. So if I have 2 protons or 2 positives, I need 2 negatives. And so these are my protons, neutrons, and electrons in this case. Okay? All right. Now, let's just do another example. So let's say I go helium-5. So what I want you to know is these are what we call isotopes. Remember, they're the same element, but they're different types of the same element. They have different mass numbers. Let's do their protons, neutrons, and electrons. So we know that the number of protons is 2. Now in this case, the number of neutrons is going to be 3, right? Because 2 plus 3 equals 5. And then the electrons are 2 because this is neutral. So notice, if you change the number of neutrons, you have what's called an isotope. And isotopes have different mass numbers. All right, let me give you another example. Let's say I gave you magnesium 25. How many protons, neutrons, and electrons? All right, so First thing, to figure out magnesium, I can figure out protons. I look at the atomic number, it's 12. My neutrons, remember, the neutrons is the protons plus the mass number is the protons plus the neutrons. My mass number in this form, which we call the isotope form, is right here. So basically, 25 equals my number of protons, which is 12, plus the number of neutrons, right? So if you look here, the number of neutrons should equal 13, because 12 plus 13 gets me 25. Or you can say 25 minus 12 gives me 13. And then this is a neutral atom. There is no charge. And so therefore my electrons have to equal my protons. Okay, hopefully this helps.